All right, welcome everyone to our next session, and we have with us today Eric Money, who is the Associate Director for Professional Education here at NC State within the Geospatial program where we offer degrees, and he's going to be speaking with us about challenges and opportunities for implementing an informal K through 12 after school GIS program. And I've been looking forward to hearing about this program. Thanks, Eric, for being part of this and for your presentation. If anyone has questions, you're welcome to submit those as well as we go along. We'll have time at the end for those questions. Okay, thanks, Eric.
Thanks, Jeff. And thanks everyone for joining this afternoon. As Jeff mentioned, I am Eric Money. I have several roles in the Center for Geospatial Analytics at NC State. I am the Associate Director of Professional Education, and in that role I also serve as the Director of several of our graduate programs in Geospatial Information Science and Technology, and I'm also a teaching professor teaching undergraduate and graduate level courses in the program. But today what I'm going to be talking to you about is essentially the culmination of a 3-year project where we received some funding to develop an after-school K-12 program dealing with GIS and geospatial technologies. And the title of the presentation here, Challenges and Opportunities for Implementing an Informal K-12 After-School GIS Program. So I'll walk through sort of how we developed the program, a little bit of context for how it was set up and some of the goals that we had from the beginning when we were developing the program. And then I'll end with just kind of a general discussion about some of the things that we've learned over the 3 years that we were able to do the program, some of the challenges and successes that we've had in doing this. And as Jeff mentioned, I'll be happy to answer questions at the end. So our primary question as we were going into this and as we were preparing the proposal that was submitted for this project was, can GIS be used as a tool to increase underrepresented student interest and engagement in STEM-related study and careers? And so we wanted to kind of look at this idea of you know, there's a lot of interest and there's a lot of work in the area of STEM engagement and trying to increase, you know, interest and enthusiasm, particularly among underrepresented groups in STEM. And so we kind of wanted to take that angle with this and to maybe take it a step further and look at, you know, can GIS itself be used not only as a tool to increase interest in GIS and geospatial science as a field, but also in general, can it be used as a way to increase a student's general interest in STEM-related study and careers? And so we set out with several different project goals. The first being to engage students in community-focused decision-making using geospatial science. Second was to increase student capacity for creating and using interactive geovisualization technologies. And then third, expose students to what we call GIS-STEM related college programs and careers. So how do we do this? So our target audience, as I mentioned before, we really took the angle of trying to reach out to underrepresented groups in STEM, and we decided to focus really on high school age students. We felt that age group was really primed for where they're at the point in their lives where they're starting to really think about their futures and think about where they want to go after high school, and looking into you know, possible majors in college or career pathways and things like that. And so we really thought that was a good age group to try to target for this particular program. And so we looked at 8th through 12th graders, primarily from underrepresented groups. The program format, we decided, there's lots of work in both the formal K-12 space as well as informal spaces, whether that's after-school programs or summer camps or museum camps, those types of things that are more informal settings. And we really opted for an informal setting for a number of reasons. One, it provided us with greater flexibility in terms of when we would be able to offer the program to meet the needs of the students that would potentially participate, and flexibility in the curriculum and the approaches that we were taking in the program to teach students about GIS and geospatial science. And so we ultimately decided, should it be after school, like immediately after school during the week, or on the weekends, in the summer, during the regular session. All those kinds of things were things that we discussed at length in terms of how to develop this and make it as accessible as possible, something that would hold the students' interest throughout the length of the program. And so ultimately, what we decided on was this program called, we ultimately called it GAPS for High-Tech Teens, where GAPS stands for Geospatial Applications for Problem Solving. And so GAPS ultimately ended up being an 8-week program where it would run each fall and spring. So during the actual sort of normal academic semester for most schools, understanding that there are also year-round schools and things like that. But we would run it each fall and spring, and it would run on 8 Saturday mornings, essentially sequential Saturday mornings, back to back. There would be a couple of times where we might break for a week for a holiday, or a school holiday or something like that. But in general, it was basically 8 back-to-back Saturday mornings, and we would run from 9 a.m. To noon. And that's essentially how the program was structured over the span of 3 years. We had different cohorts each fall and spring. Cohorts would consist of up to 20 students. We would generally always sort of max out at 20 students. And so we really taking sort of a broad view of GAPS and what it was what were the foundations for GAPS. Really these four foundations, starting with connecting. So one of the things that we really wanted to try to do was to connect students, both with each other, but also with geospatial professionals, researchers, and like I said, their peers from other schools in the area. We wanted to make sure that they had the opportunity to explore. So again, offering students structured activities to explore cutting edge technologies in GIS. We wanted to give them the opportunity to discover, so allowing them to discover how GIS impacts daily lives and how it can help solve community problems or problems that may be relevant to them and where they live or where they go to school. And then finally, allowing students to build GIS skills and apply those skills to a real world project. And so this is just a breakdown in a little more detail about those 8 Saturday mornings that we would conduct for the program. Like I said, they would begin at 9 a.m. every morning and we would go until noon. These would be held off-site, so because we pulled students from schools around the triangle, and even occasionally we would get students from as far away as Forsyth County, Winston-Salem. We occasionally had a student come from that, but most of them were in the triangle vicinity, but from a lot of different schools. And so we were able to collaborate. And I should say, this is not just me doing this work, but it's a huge collaboration between us and a number of partners that I'll talk about at the end. But one of those partners was the Wade Edwards Learning Lab based here in Raleigh. And they do a lot of after-school programming. And so we worked with them. They had space for us where we could set up the program. And so students would congregate there on Saturday mornings. and we would start the program that way. And so on the first couple of days, it was more introductory, getting to know each other, getting to know about the program, and starting to talk a little bit about some of the sort of fundamental concepts of geography and geospatial science. And so we called this space and place on day one, and tools and tech on day two, where students really are just they just kind of jump in, start working with maps, learn about how maps are used in their daily lives, how GIS maybe influences things they do and they don't even know it, and then introducing them to some of the GIS technologies that they're going to be using in the program, and other technologies that they may not actually use, but that just make sure that they're aware of those types of things. By the third day, we take them on a field trip, or we take them on a field trip to NC State and the Center for Geospatial Analytics, where we have a really state-of-the-art geovisualization laboratory. And so in that lab, we were able to, again, expose them to a lot of newer advanced GIS technologies that they may not otherwise have had exposure to, either inside or outside the classroom. And so we really focused on modeling and geovisualization during that. We got to interact with a number of our graduate students in the program, but also interact with researchers and faculty that work with us in the center. And so they got exposure to sort of that side of things as well, in addition to all of the sort of cool technology that we do there. They got to do things like virtual reality, Python coding exercises, sand tables, tangible landscapes, eye tracking, just a lot of interesting applications that we do at NC State, and a lot of hands-on activities that day. Then we come back to the Wade Edwards Learning Lab on day 4 for the remainder of the program. Day 4 is really focused on scientific and professional discovery, where students begin to sort of storyboard project ideas. They're at that point put into project teams for some activities. We also bring in a panel of geospatial professionals to kind of talk about their experiences, their education, their backgrounds, and how they got interested in GIS and what they do on a day-to-day basis. Day 5, we really explore more activities in map making, do things in ArcGIS Online, and other web-based tools. And then days 6 and 7 is really devoted to working in their project teams, where they basically were tasks where days 4 and 5, they were working on developing sort of project ideas, questions. We kind of let them decide. We did a lot of brainstorming activities together as a group, where they would sort of throw out different, disciplines or just different things that they're interested in, whether it was crime or water quality or public health or any of those kind of things. And then we narrowed that down into, 6 or 7 plausible topics, and then the groups would form around those individual topics. And from there, they would kind of develop their own question, storyboard their ideas, and then ultimately develop a story map using ArcGIS Online to pull in some data that they may have found and create some maps and visualizations. And then on day 8, the final day of the program, we would always end with a program fair where we would invite the parents to come in, others, the panelists that had come, back in day 4, and other folks to come, and the teams would actually present their story maps in sort of like a conference poster session would normally run, and we would do that activity as kind of a closing out of the GAPS program. And so in terms of who we were able to bring into the program, by the end of the 3-year period, like I said, we had 6 different cohorts, 20 students in each cohort. So for a total of 120 students, and that's what some of the results that I'll be presenting over the next few slides will be based on those, sort of a compilation of those students. And so just first a breakdown of grade level. Again, our target was 8th through 12th grade, but we did occasionally get someone younger than that. We tried to to not allow someone younger than 8th grade just because it starts to change the dynamic quite a bit. But we did, every cohort, we definitely had a mix of 8th graders, 9th graders, 10th graders, 11th graders, and seniors all in the same program, which I think is somewhat unique to programs that have existed maybe similar to this that are out there. We thought it was really important to have those groups working together, and it usually was pretty evenly distributed, but it did sort of skew towards the lower end, the 8th to 9th graders, as you can see in the pie chart here. We also tried to keep the gender balance pretty even across the program, and so it was basically 50-50. Individual cohorts were oftentimes slightly higher female percentage than the male percentage, but ultimately it ended up being fairly even if you look across all cohorts. In terms of other demographics, like I said, we were really trying to bring in these underrepresented groups. And so we really tried to sort of expand beyond white. And as you can see, we had a large percentage of Black or African American students, a large percentage of Hispanic and Latino students, some American Indian students, a large portion of Asian students, and white students. And so during each cohort, there's also a mix of students from those different backgrounds, varying levels of socioeconomic background. That is one thing I'll talk about towards the end when I talk about challenges. That's something that's really hard to kind of quantify when you are soliciting participants to apply to the program. And so I'll talk a little bit about that aspect as well. And then finally, this last graph here on the right is just showing you all the different avenues that we tried to recruit students into the program. And there were basic internet searches, so we had a website developed for the program. We had social media posts that would go out via our partners. We would have the North Carolina STEM Center website. We would post the opportunity on there. And you can see that ultimately what became sort of the largest driver were friends and peers, which is great, word of mouth from their peers that have gone through the program and recommended it to their peers. And then also the recommendations of a teacher. So getting the announcement of this program out to teachers and then the teachers disseminating that to the students became a really important component of being able to grab participants for the program. In terms of the activities that we did with them, specific activities, we would always have what we call daily templates for each of those Saturday mornings, where we would essentially, for the team that was there, the GAPS team of staff that were there running the curriculum and things like that, we would have it broken down by 15, 30-minute segments of activities. We would also often run them in parallel, so we could divide up to 20 students into sort of 10 and 10. Run simultaneous activities, and then they would switch just so everyone would get exposed to the same activity. But certain things were a little unwieldy with trying to do everything with all 20 students at the same time, which sort of our first cohort, we were doing it that way and really learned from that doing things in parallel really worked out a lot better. And there was a lot more interaction among the students. And so these are just some pictures here on the left of some of the different activities that we had. We had people come in from like the EPA. They did like an Enviro Atlas activity. They did a citizen science activity using GIS. We did a lot of tangible landscapes when they were visited NC State, so doing sort of modeling with their hands. We also did a lot of ArcGIS online exercises and web-based exercises to try to teach them some basic concepts and things about spatial data, visualization, and those kind of things. And then this final thing here on the right is just an example of one of the cohort's project fairs from spring of 2019. And you can just kind of see the varied nature of the types of things that the students ended up being interested in. We had one group do a story map on crime in Lake County. We had another do one on veteran access to hospitals. We had another doing factors affecting access to healthcare in a more general sense. immigrant communities, victim populations, water pollution. So, and these were things that we allowed the students to really try to drive the things that they were interested in, the things that were on top of their minds, and then how they can apply and use GIS to help them understand that particular topic. And so in terms of evaluating what we were doing in the program, we partnered with the College of Education here at NC State to help us deliver some pre and post survey instruments. We did some pre-surveys, the STEM semantic survey and the career interest questionnaire. We also did that in sort of after the program to see if there was any change. And really what we wanted to try to evaluate was change in competency. So were they able to sort of improve their GIS skills, change in interest, both from a GIS perspective, but also just in a STEM discipline perspective, and then change in enthusiasm. And so those instruments are really designed to look at some of those things. And so on the next several slides, what you'll see on the left will be, these are quotes that we're taking from the surveys that we gave to students, either, pretty much after the program. And then there'll be some metrics on the right of how some of the survey results. And so these two blocks on the right, the 4.7, these survey instruments were based on a 5-point Likert scale. And so a pretty high level of agreement that GAPS kind of helped me understand geospatial science better. And so that's great. I mean, obviously that's one of our goals of the program was to get students competent in GIS and understand what it is. And then similarly, GAPS helped me to apply geospatial science to real world problems. Again, kind of high level of connection with that. In terms of interest, again, another quote here from a student on the left. But one of the things that we saw here is that when we compared, taking the survey prior to the start of the program versus after the program, there was across the board, if we look at all the cohorts, there was a 20% increase in the number of students that expressed interest in STEM careers, prior to starting the program compared to after the program was over. And then there was an 8% increase in the Likert score, on a 5-point scale, for the question, I would like to have a career in science, and again, comparing that to pre versus post program. In terms of enthusiasm, again, another quote here from a student on the left. But 72% of the STEM semantic questions on that survey saw an increase on their scale when comparing it pre-CAPS program versus post-program. And 4 of those survey items had a statistically significant increase pre versus post-program. And those were science means a lot. So there was a statistically significant increase in the statements, science means a lot to me, pre versus post program. Similarly with math is appealing, engineering is fascinating, engineering means a lot. So all of those saw a significant increase in enthusiasm. So just to kind of conclude, and some of the things that we've learned from implementing this program is that overall, we felt like the GAPS program was able to demonstrate that GIS as a tool can be used to increase interest and enthusiasm in STEM and also GIS specifically. In terms of challenges, recruitment, and I think any of you that are out there that have tried to recruit for these types of programs in the past know that particularly if you're trying to target underrepresented groups, it can be a challenge to make sure you're reaching those. We would find that the students were sort of automatically biased towards liking STEM before they joined the program. I think that was just by the nature of the teachers that we reached out to and the students that they ultimately then passed this on to, for example. And so it would be better, I think, moving forward to really try to reach some of those maybe underperforming schools in various districts, really trying to reach those students that have less access to some of these things and some of these ideas, and bring them more forward and recruit them a little more heavily than we may have done in this program. We did find that there was lots of demand. By the last cohort, we were averaging 120 applications for 20 spots. We always struggled with how much was enough. You know, we had limited time. We weren't sure how much sort of background in geography and those kind of things we needed to do versus jumping right into GIS. We also had to add, sort of juggle access and tools. And so ultimately, you know, 90% of students that were coming into the program had no idea what GIS was. And I think we ultimately were able to kind of change their minds on that. And so I will leave you with sort of these final thoughts from a parent. I think this is really sums up the program really well. We also did a parental survey of students. And so I'll just quickly read this. You know, students gained an understanding about a field of study that as a parent, I didn't know existed. She came home and shared tools like the Enviro Atlas with us, showed us how to use them, and as parents, we were blown away. She likes science and technology, but hasn't engaged in anything beyond the classroom that marries the two like this program did in such an incredible fashion. I think this experience has definitely sparked a possible career path for her that we were all unaware of. This I'm very grateful. And it just goes on to say that the kids gained real world experience to working with students that they didn't know. The mix of students from different schools and backgrounds was great. And so this really kind of summed up in a succinct way a lot of the things that we were hoping to achieve with the GAPS program. And so I just want to end by acknowledging all of our different partners. I did not do this alone for sure. There are lots of great people that helped us. This was a partnership with RTI International. It was funded by the Board's Welcome Fund, Student Science Enrichment Program. Again, I mentioned the WELL in the past, with Edwards Learning Lab and the NC State College of Education. And these are all of the people that worked with us, help us deliver the curriculum and teach during the program, work with the students, do the surveys, and all of that great stuff. And this is in addition to all of the panelists that came in and others that helped us throughout the way. And so with that, I'm happy to answer a few questions. I think we have a couple of minutes left. Here's my contact information. Feel free to reach out. I'm also on LinkedIn. Just look up for my name, and I'll be happy to discuss more.
Thank you, Eric. Outstanding. That's very interesting and great work. Really impressed with what you've done. We've got just a couple minutes for a few questions. I think I've got about 4 questions actually, so we need to kind of go through these quickly. The logistics, as far as were you using ArcGIS Online or is other desktop software?
Yeah, so for the most part, for the built-in GIS activities, we did use ArcGIS Online just because it's web-based and pretty easily accessible and something that we felt like students potentially would have access to in the classroom in a more formal setting in their schools.
Okay. And you were providing laptops, I guess? And
we did. As part of the funding, we were able to give, we had 10 laptops for 20 students, so they would share whenever we needed to do that. Yeah.
Okay. I want to get to this one question. It came in kind of late, but I think it's a lot of people may be wondering, is the program still open and are you doing it virtually?
Right. So our funding actually ended, well, technically it ends this year, but the program ran through last spring. And last spring, obviously the pandemic hit kind of midway through our last spring cohort. Ultimately, because everything that we had done was designed to be in person and hands-on, we did not transition that spring cohort to virtual, and it would have changed sort of drastically our approach. And so we felt like because we were already nearing the end, that to try to switch it to virtual didn't make a lot of sense. And so we have not done it virtual. So everything was always in person. Yeah. So.
Okay. I think I'm not sure what happens at 12:30, but the last question we'll talk about is the curriculum. If you got it somewhere, or if you're able to make it available to others, or if it, was it developed in-house? And
that's a good question. Yeah, so we did develop it in-house. Obviously, we pulled from some existing things that may have been out there and added in some new things from our own experiences. We do have the templates that we use each day of the program. We're working on sort of getting those in a format that is going to be usable for folks. But one thing we also did try to do was to connect those activities to actual North Carolina education standards as much as we could. And so we have some of those sort of mapping that we did, mapping those to that as well. So hopefully we'll be able to share them once we really fully wrap up the program later this year.
Okay, thank you, Eric. The chat has disappeared. I don't know if that means other people are still able to watch or not. I'm going to find out. But I will say a lot of people said that they really liked the presentation and wanted to thank you for it. So I was going to try to capture that before it disappeared, but it's gone. But yeah, a lot of people said it was really awesome, and I totally concur. So